How Taya Talks, building an AI voice chat system in Python. The pipeline is 5 steps. Your voice is captured from the microphone using WebRTC voice activity detection. The audio is sent to OpenAI Whisper for transcription. The text goes to GPT-4o, which generates a response. Hyper converts that response to speech. The audio plays through the speaker, and throughout, Taya's face changes state to match what she's doing. Before the first word is spoken, 3 memory layers are assembled into the system prompt. Canon is Taya's permanent identity, facts about herself, preferences, and history stored in GitRacked Markdown files. Transient is her current embodiment. When Taya is in the van, the robot chassis, or the house, files describing those capabilities and sensors are dropped into a directory, and she reads them automatically. Presence, expression, augmentation, defines her personality and communication style from a JSON file. All 3 are joined and injected as the system message before any conversation starts. Canon lies in a directory called memory canon/canon data load. All Canon reads every markdown file in that directory and returns a dictionary mapping topic name to content. At startup, those contents are joined with double-dashed separators and prepended to the system message. Changes are committed to Git, so every update to Taya's memory leaves an audit trail. The update canon and commit canon functions let any part of the system write new facts and record them permanently. Transient memory is Taya's sense of what body she is currently in. When she runs in the van, a file describing the van's GPS, radio, and climate controls is placed in the transient directory. When she runs on the robot chassis, a different file describes its sensors and actuators. At home, the home of devices. The transient data manager reads every file in that directory, hashes the combined content, and checks every 5 minutes whether it has changed. If it has, the system message is rebuilt, so Taya's capabilities update live without restarting the process. PVA file is a JSON document that defines personality. Presence covers identity, name, persona, and traits. Expression covers communication style, response length, tone, language. Augmentation holds platform-specific overrides. Build system message assembles these fields into a single string that becomes the final section of the system prompt. Swapping the PVA file gives you a completely different personality without touching any other code. Recording uses WebRTC voice activity detection. The microphone is sampled in 100 millisecond chunks at 16 kHz. Each chunk is tested for speech. Once speech is detected, the recorder keeps going and stops automatically after 1.5 seconds of silence. No button to press. No fixed duration. It just listens until you're done. The 3 core steps are each a thin wrapper. Transcription sends the WAV file to Whisper and returns a string. Chat appends the user message, calls GPT-4o, logs token usage, and how many prompt tokens were served from cache, then returns the reply. Speak pipes the reply text into Piper, and plays the resulting WAV through a play. The Piper flags tune speed, naturalness, and sentence pausing so the voice sounds relaxed rather than robotic. The main loop is straightforward. In voice mode, pressing enter starts a VVD recording. The audio is transcribed, sent to GPT-4o, spoken aloud, and appended to the conversation history. Before each call, the loop checks whether the transient data is due for a refresh, so if you've changed bodies mid-session, Taya picks that up automatically. Text mode, conversation save and load, and VVD toggling are all single-word commands handled before the API call. That's the full Taya voice chat system. 3 memory layers, voice activity detection, Whisper for ears, GPT-4o for thinking, Piper for a voice, and a face that reacts to all of it. Code will be up on GitHub soon. Thanks for watching. Be good. Be well.